Welcome to our final session of Track E, the International Track. I'm Carl Gerber, Chief Data Officer for Deloitte US, and I'll be your track producer. The MIT CDOIQ Symposium continues to expand our global reach. We have had an excellent lineup of sessions in this track that bring a world view. You are in session 19E, the Building Information Model, Digital Twin, and Data Management session. BS/PAS 1192 defines the building information modeling, ranging from level 0 to level 3, depending upon how well the data is structured and how much technology is used. It defines basically the evolution of the tangible asset information expression, starting from paper and document-based models to data and information-based models. Digital twin, on the other hand, is the exact reflection of certain reality, and each piece of the data within represents a fragment of the reality. It works the other way around as well. You can remote control the reality by manipulating the digital twin. However, if the quality of the data is not satisfactory, wrong reality will be constructed, and it becomes dangerous to control the reality using the digital twin. In general, the more data is integrated, the more they make sense, and the more they impact decision-making. But if they are poorly integrated, the constructed reality will be distorted, becoming farther and farther apart from the true reality, which will be no more a twin. When we look at BIM, from data management perspective, it is simply the result of asset data integration, including XYZ special attributes. BIM can be enhanced if the fourth dimension, time, is augmented. BIM can further be enhanced if alternate reality data, the scenario data, is added, expressing multiverse, so-called paradelle world. Those wonderful aspects of BIM, or digital twin, can only be achieved through careful planning and strong data management. This presentation will show the steps to produce better BIM and better digital twin, including data architecture, data integration, and data quality management. Case studies in Japanese companies and in the Asian region will also be introduced. So a little housekeeping for this session. It's being recorded. This and all these sessions from the symposium, together with the presentation materials, will be made available to all participants. This session also has a poll for the audience. Please go to the poll tab in the Whova application and answer the questions that are there. Additionally, you can submit questions via the Q&A tab. On the Q&A tab, you can also vote up the questions that are there so we can be sure and answer the high priority ones. Now I will introduce our speaker, Mik Hayashi, the DEMA Regional Coordinator for Asia. 32 years of professional experience and knowledge in information management in various fields such as database, system architecture, requirements analysis, and project management, as well as rich experiences in various business domains. He is taking leadership for data-centric initiatives in the international EPC industry with international data management standards and modern system architecture. Chairman of DEMA, the Japan chapter, and Asia Pacific Regional Coordinator of DEMA International. He is a frequent speaker at Enterprise Data World in the US as well as in Japan. He is currently working in JGC Corporation as Chief Advisor of EPC DX Department, focusing on enterprise data model, digital transformation, digital twin, and BIM. Mick, the floor is yours.
Thank you, Cole. Okay, shall I share my screen?
Yes, please.
Okay. Can you see it?
Yes, I can see your screen very well.
Okay, let's get started. All right. Hello, everyone. I'm Hayashi from Japan. I'm going to present the BIM digital twin and data management from a user's perspective. This is my first time to present in MIT CDOIQ conference. I'm very, very nervous. So it's, actually, I got my hand shaking. So please help me. Okay, so let's get started. Okay, so BIM digital twin, and further than that, we can talk about AI, but in any case, we have to focus on data quality, data governance, and data management. Let me start with my self-introduction. Okay, I'm working for JGC as introduced. I have been an information manager for various projects, and currently I'm a chief advisor of a digital transformation department. And as a DAMA, I'm an APAC regional coordinator and the DAMA Japan chapter president. And we translated DMBOK version 2 into Japanese. Right, I was participating International Industrial Standardization Organization. Okay, some of you may know or may not know about the industry initiatives like ISO or IOGP. It's Oil and Gas Standardization Organization, and CII, which is Construction Industry Institute. I'm a board of advisors. Okay, look at my icon. I mean, does it look familiar? We are not a software company. We are actually just an end user. So I'm presenting this case from a user's perspective. Okay, GGC Road to Digital Transformation. Okay, first, what we do is that we construct oil and gas plant or chemical plants. Sometimes it's huge plant, like more than $1 billion or $10 billion sometimes. And we have successes and failures, and we are trying to improve what we do by introducing digital transformation. Right. In addition to that, we have an affiliate company, which is called Mods in the UK. And we are trying to create digital solution for project. Right. So Mods is creating industry software for EPCs and operators. Actually, we have started to build those solutions together. Okay, so in this presentation, I try to put in sort of 3D or animation favor into the slides. So please bear with me. There are certain, you know, like playing toys like this. Okay, so what we do is basically building information modeling, right? So BIM, we start with the discipline 3D models like architecture, structure, air control, and electrical and piping. So we integrated these models into one 3D model. And then we add like 3D scanning of existing facilities. For example, we design the plant, and after we build the plant, we scan, we call it laser scanning, and then we can see the differences between the built one and the engineered one. And we also sometimes place equipment 3D models, which is actually not just a box, it's like a working object of equipment such as pumps, compressors, valves, and those things. And then we have been trying to achieve virtual reality, mixed reality, engineering. So virtual reality, view architectural elements like finishings. Sometimes we put people moving around in the virtual reality. All right, mixed reality, project 3D, project actually is 3D models against the reality, imaging the completion. Right, and then 360-degree panorama view, omnidirectional image such as Google Street View. Right, you could see this, right? I will show you an example. Okay. Can you see this image? All right, this is
Yes,
very simple. Okay, very simple example. Right. And then these, the equipment models. Right, so these 360-degree panorama view is used for greenfield and brownfield. So this is technical term. Allow me to use sometimes our EPC, that means EPC means engineering, procurement, and construction project. So greenfield is to build a new plant, and brownfield is renovating existing plant. So these technologies are used for both cases. Right now, the next example. We simulate environmental impact. So such as aerodynamic analysis, including airflow, heat distribute, humidity analysis in clean rooms and warehouses. Illumination analysis, light environment through natural light and luminescence analysis. And remote engineering, promotion, and GMP training. GMP is the term used for medicine factories, good manufacturing practice. All right, so well, many of you should be familiar with the remote communication, but in our case, we use 3D models and hands-free engineering environment between two operation centers. And remote 3D review, accessing the unified 3D model from multi-locations. And promotion and GMP training, creating promotion videos using 3D models, conduct remote GMP training. Okay, now in this presentation, I'm going to talk about basically two things. One is BIM and digital twin. What are they? What they are and the differences between two of them. Right, then the second half is going to be a data management topic, introducing DAMA and data quality and data management challenges.
Mick, before you go on, I would like to give you the results of your audience poll.
Yes.
So you asked the question, are you familiar with BIM? 17% of your audience said yes. Familiar with digital twin? 42%. DAMA? 13%. And the DMBOK? 29%. And you had a total of 24 respondents to your poll.
Thank you, Carl. This is very informative. Right, so I'm going to talk a little bit slow so that anybody who don't know about BIM or digital twin or DMBOK would understand. Okay, now start with BIM and digital twin. Okay, BIM is called building information modeling. This is not model, it's a modeling. And sometimes we have civil information modeling. So actually it's a similar thing. Right, so I start with very official definitions. ISO 19650 defines BIM as use of a shared digital representation of a build asset to facilitate design, construction, and operation processes to form a reliable basis for decisions. Okay. On the other hand, the US National Building Information Model Standard Project Committee has the following definition. BIM is a digital representation of a physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle, defined as existing from earliest conception to demolition. As you may have noticed, there are some common terms used here. Right. First of all, is digital representation. And second, it's used for making decisions. And third is shared. So please remember these 3 points. Okay, so BIM standard, as far as I know, it's actually started in British industry standard or publicly available standards, both of them in the UK, right? So we call it PAS 1192, Part 2, which is the above one, and the Part 3 is the orange one. Okay, so they are describing specification for information management for the capital delivery phase of construction projects using building information modeling. Okay, so in 2013, PAS 1192 Part 2 was released for design and build phase, which is for project phase, the building phase, right? So this describes the BIM maturity levels. I'm going to explain this from level 0 to level 3 and the project information model. So that means it's obviously focusing on the building plans phase. Then common data environment for PIM, project information model. That means sometimes we call it CDE. CDE is the data repository to be shared among many parties to a lot of them are stakeholders, right? Then sharing decision making. Well, this is the foundation for BIM. And the next year, 2014, PAS 1192 Part 3 was released for managing and operating phase. That means operating the plants. So this focuses on asset information model instead of project information model. And again, common data environment, for this case for AIM, asset information model. So these two documents have been consolidated into ISO 9650. So currently, these past standards have been withdrawn, but instead, ISO 9650, which is a new standard, is actually being worked out. Okay, so I borrowed this picture from British Standard Institution. Right, so this is a part 2 for project phase. And then here is part 3 for operational phase. Okay, please remember project information model and asset information model. Okay, now I picked up few keywords and terms in the previous definition. I repeat that again. First, BIM is digital representation, right? For project information model and asset information model. And then how much information it should contain is dependent on the maturity level from level 0, 1, 2, and 3. And then basis for decisions. So BIM is used for decision making. So that's why employers, which is actually the owners of the plants, they give information requirements to the contractor. to enable their own decision making. Okay, so number 3 is share. So they created the concept of collaborative method of work for decision making. We call it common data environment. Okay, another one is we call it construction operations building information exchange. This format is used to exchange information among various parties. Okay, now I talk about maturity levels. As I said, which covers the level 0 until level 3. Right. So level 0 is just simple CAD. This is just the design, right? So this is still paperwork, which contains only basic asset information. It's a paper. You can copy it, but basically no collaboration model. Okay, level 1 is still document-based and with a little bit of collaboration, includes 2D and 3D. So since the paper only can produce 2D drawings, but now it's 3D, but it's like documents. You can see perspective views or maybe various angles, but still low collaborative documents. Now level 2 and 3, right? So this is the real BIM, if you will. Okay, so level 2 has full collaboration, and level 3 is full integration. Okay, so these are the electronic forms, and okay, the world of data instead of documents. So level 2 is full collaboration. 3D models are used and share information, and common data environment, and then we have to hand over the actual asset. Okay, so this is real world. So this real world and virtual world should interact each other and reflect each other. But, all right, so now the data quality is the issue. So as Carl explained in the introduction section, that if we actually collect the wrong data or we use incorrect data, then we have incorrect virtual world. So that's the focus on this presentation. So now, okay, I'm going to talk about digital twin. We start with definitions again. Okay, according to Wikipedia, digital twin is a virtual representation that serves as a real-time digital counterpart of a physical object or process. Okay, remember this doesn't say 3D or graphical. So it's only say real-time digital counterpart of a physical object or process. The first practical definition of digital twin originated from NASA in an attempt to improve physical model simulation of spacecraft in 2010. So digital twins are the result of continual improvement in the creation of project design and engineering activities. Product drawings and engineering specification progress from handmade drafting to computer-aided drafting, computer-aided design, to model-based system engineering. Another definition comes from ISO. Okay, the number is 23247, manufacturing digital twin. Okay, so this standard has not been complete. This is under development. But then please remember this ISO is actually focusing on only manufacturing digital twin. So under section 3.2.2, terms and definitions, digital twin is defined like this: manufacturing digital twin, fit for purpose digital representation of an observable manufacturing element with the means to enable convergence between the elements and its digital representation at an appropriate rate of synchronization. Okay, yet another definition comes from IBM. They call it cheat sheet. What is digital twin? Digital twin is a virtual representation of an object or system that spans its life cycle from start to end, is updated from real-time data, and uses simulation, machine learning, and reasoning to help decision making. You may have noticed again the common terms are used here. So one is a virtual representation or digital representation. And number two is decision making. Right. So now this slide actually contains animation and graphics actually created my daughter. Okay. So digital twin in the mirror. Okay. This is my daughter in the digital twin. Actually, my daughter is only a child, so no twin. But then, okay, so this is actually complete one-way digital twin. Her name is Yuri, and this is Yuri number 2 in the mirror. Okay, but then sometimes we have accuracy problems. You can see the shapes are not properly formed, and completeness problem. You can see it's missing colors. You can see integrity problems. I mean, number of legs are 3 instead of 2, and then it's just installed to very strange position. Okay, but then they are all static model. So now I'm going to talk about dynamic model. Okay, so now this is digital twin, but it works in both ways. Right now, it's right. So one side turns, and then the other side turns. Okay. Then one side actually smiles, the other side smiles. Can you see that? One side is actually not feeling well. The other side is also not feeling well. So these are the dynamic model. Hopefully you can get some ideas. Yeah. Okay, so now I combine beam and digital twin together, and I'm going to explain in integral definition. Okay, first dimension, second dimension, third dimension. It's all geographical data, okay, representing shapes, objects, and entities. Now we add fourth dimension, which is time. Okay, then we can carry out what-if analysis, and then we can incorporate slowly changing events such as building foundation, structures, piping, and installing equipment, which is actually one day or a few weeks or a few months events. It's still slow. But then instead we can have fast changing event. It's like a minute or maybe seconds. And then we can also have a real-time event, which can be really microsecond world. I mean, in the oil and gas plant, we actually have been doing this almost real-time event handling for many, many years. So one side is like, for example, if the fluid level is going up more than the critical level, then the valve should respond to that event and then close the valve. So this has been happening in every plant. So these time events and 3D, that means the geographical data, can respond. So they are responding each other's. And then we introduce fifth dimension, which is cost and resources. So these costs and resources will be impacted by 3D, of course. We install or remove or change layout all the time. If something breaks down or something is changing, which will impact costs and resources. And the sixth dimension and seventh dimensions is actually facility management, like safety, environment, and performance. Okay, now physical reality here and the virtual reality here is actually corresponding each other. Okay, now I'm going to categorize beam or digital twin. Okay, so let me focus on the digital twin, which includes 3D models, which is almost manufacturing digital twin. Okay, so we have 3 models, right? First of all, at the center, we have engineering digital twin, right? And then we have basically, of course, 3D models, including site, layout, equipment, piping, cables, instruments, structures, civil and building. And PID, which is we call it process drawings. And engineering logic and calculation data sheets. Many of them could be in the documents or in the data form, right? Now, when it comes to project digital twin, we introduce time axis. I put a P6, which represent Primavera scheduling software, version 6. This actually introduced milestones and duration of the project activities, okay, including construction resources, temporary facilities, cranes, camp, scaffolding, access roads. And then here we call it AWP, EWP, PWP, CWP, which is actually representing work packagings. So AWP represents advanced work packaging, and then which contains engineering work package and procurement work packages and construction work packages. So they are all contained in the project digital twin. And then once the plant is complete, and then it starts operation. So the operation team will, of course, they put raw material into the plant, such as crude oil, natural gas, chemical. And then they use gas, electricity, water as utilities. And the plant signals, we call it distributed computer systems. As I said, like the valves are responding to almost real-time events of fluid, temperature, level, pressures. And then they keep track with products and byproducts, gasolines, energy, diesel, methane, propane, ethane. Okay, now, as you can see at the center is a core trustable model, which should be engineering digital twin. So if we design in the wrong way, or we actually represent engineering digital twin in the wrong way, it will actually corrupt project digital twin as well as operational digital twin. Okay, so how they are used. So we basically, we have, well, just very, very roughly, we have a design, build, and operate. So I put all this project life cycle, that means, sorry, plant life cycles into 3 phases. Okay, now, after we build the plants, we complete the plants, we hand over as built, planned, as well as built information or data for the operators. Okay, now, engineering BIM or digital twin here is actually, it survives from the very start of the project phase until the operation ends, which carries out what if analysis simulations. And then while we are designing a building plant, we use project BIM and digital twin, which tracks slowly changing events. Right, design change or equipment is purchased or installed or commissioned, tested. Okay, then operation asset BIM and digital twins is used for operation, of course, which keeps track with the real events, fast and real time. Okay, so this engineering BIM or digital twin serves for both purposes. Okay, then this engineering BIM, this model needs to be trustable. That means information quality is the key. And then BIM digital twin is not really a one-time effort. I mean, as you can see, it survives from the very beginning until the end of the plant life cycle. And it should be constantly updated, reflecting realities and, editing attributes, So it needs continuous efforts to update for the whole life cycle. Okay, let's compare BIM and digital twin. Okay, focus on level 2. Right, now level 2 BIM is here, digital twin is here. So we have a common characteristics here. Okay, first of all, 1, virtual representation. Okay, graphical models is basically for BIM, but the digital twin can have graphical models. And then time dimension. So BIM, it deals with 4D, slow and fast reflection of the reality. And digital twin is usually almost real-time reflection of the reality. And then both BIM and digital twin have non-graphical models. For BIM, we have cost and resources and facility management models. And then digital twin can have a statistical model, or process models, sometimes even for medical models. Okay, now both of them serve for basis for decision making. Okay, for BIM, how do we help decision making? By facilitating design, construction, operation processes. Digital twin supports decision making by using simulation, machine learning, and giving reasons for the decision making. For example, if we conduct what-if analysis and simulations, the management will know which case may yield the best result so that they can make decisions based on those information. Okay, so information is shared basically for BIM, but of course digital twin can be shared, but it's not a must for digital twin. So as you can see, number 1, virtual representation, 2, basis for these decisions, 3, information is shared. Well, BIM and digital twins are almost very similar, but it can be different. But you can see actually digital twin is actually enhanced version of BIM, I would say. So here is a common characteristic: shared graphical BIM and digital twin. Hopefully you understand this comparison. Okay, so now, all right, suppose we are targeting as good quality digital twin, graphically and shared models. Okay, sorry. Now, so digital twin could be produced from BIM level 2 and level 3, which is actually, the data is fed from common data environment for both cases. Okay, now we want to transport digital twin. Now, how do we do it? We need trustable BIM level 2 and 3. How to build a trustable BIM? Now, we need common data environment. How to build a trustable CDE? Now we need information quality and proper data management. So data, lots of data is fed into data management and then transformed, collected, gathered, transformed, producing information quality through CDE and BIM, and finally, good quality digital twin. Okay, now, data management is the key to the successful BIM and digital twin implementation. I hope you understand this. You get the idea? Right. So BIM and digital twin I talked about. But other than that, we have a lot of other things like glamorous features of wonderful dreaming world. I wouldn't say dreamable, but then it's not dream already, but you can see a lot of terms you heard about, right? IoT, AI, and data science, innovations, analysis, business model breakthrough, governance, system development, agile digital transformation. But then it all comes down to data management because they are all reliant means dependent on the information quality. So, as I explained many times in this presentation, okay, here BIM, digital twin, or even AI actually is a foundation for business decisions and revolution. But they are supported by information quality, data management, which are actually supported by enterprise culture and maturity. So it's a foundation to support decision making. So decision making actually requires the right information by the right people. The right people need right information at the right time. If we feed wrong information for top management, they make wrong decisions, which we wouldn't want really. So who is in charge? So if we speak about BIM or digital twin or AI, we just instantly think about, okay, let's use that tool or this tool, right? That's not really the case. Okay, the tools can be provided by IT vendors, but decision making is for user companies. And these foundations should be built by user company. All right, so the reality to virtual representation, right? So this is actually not happen easily. So as I explained, user company has a lot of responsibility, okay, for this. Analytical models, introducing technologies. Okay, this yellow part can be can come from IT vendors or specialty vendors, yes. But then we have to choose proper technologies, proper analytical models. This is under users company's responsibility. And then in addition to that, feeding the data is also by the user company, which actually build a digital twin. Right. Now, how it happens. The feeding data, right? The reality, we collect the data from reality to feed the data to data layer of virtual representation, which will be fed to the presentation layer. Okay, data management includes preparation of design, metadata, database, resources, prepare procedures, documents, manuals, organizations, right? We measure, gather, input, transform, load data. We have to verify data, validate data, control and process, monitor the process, and we, of course, have to have a budget. Okay, so if the data is successfully fed into data layer, we can construct discipline-wise BIM, which is actually partial BIMs, which will be integrated into one uniform model, and then fed into presentation layer, which can be digital twin or dashboard or videos. Okay, so the reality is the truth. And in the virtual representation, we have to build a single source of truth. So that means if we have one truth in the reality, if we have 5 truths actually contradicting each other, I mean, we don't know which model we have to trust. So we need to establish the single source of truth. So here, the user will actually see only the presentation layer, such as digital twin, dashboard, videos. Okay, this is the only visible, layer. But then all the efforts from data management and data layer construction is still the user's company's responsibility. Okay, so here the data layer, here information quality is the key. The data management also is the key to realize information quality. Information quality is the key to realize trustable digital twin. Okay, I'm going to introduce briefly about data management framework, DAMA and DMBOK. Probably some of you may know, but just let me just go through brief introduction. Okay,
Mick,
Dharma International
15 minutes
started.
left. 15
Yes,
minutes left.
thank you. Okay, it's actually in 1980, started as a grassroots activities. You can see these chapters. We have, it's around 60 chapters right now internationally. Right, it publishes DMBOK, Body of Knowledge, and it holds the international conference. We call it Enterprise Data World, and then conduct training or CDMP. Okay, so we have Dharma International as an organization, DMBOK as published books, Body of Knowledge, and we have conferences, we have exams. Okay, now, so Dharma published DMBOK, which has a famous Dharma wheel, which contains 11 knowledge areas: data model and design, storage operation, security, integration and interoperability, document and content management, reference and master data, data warehousing, business intelligence, metadata, data quality, data architecture, and at the center, the data governance. We call this whole wheel is a data management. And now, this data quality is defined in dimensions: accuracy, completeness, consistency, integrity, reasonability, timeliness, uniqueness, validity. Okay, you could see, okay, we need to have a good product, that means good quality. So how do we define the quality of the data? Okay, many people miss the dimensions. Okay, they only imagine accuracy, but it's not complete, it's not good quality. If it's not consistent with the reality or the data, among the data, we cannot trust the data. Okay, so please remember we have these kinds of dimensions to measure the quality of the data. Okay, this is actually described very in detail in DMBOK. Okay, so now, as I said, the data quality is hard to be achieved, but BIM and digital twins are fantastic technologies, but if and only if we can trust the data. Well, according to our research in real projects, 70% of data in engineering tools were either not accurate, not properly classified, not complete, not consistent, or not updated. That's very bad. But this is what happens usually. Okay. Can you trust your BIM or digital twin based on this data? I don't think so. So why is this so difficult? Because many people think it's easy, but it's not. Data is a beast. My data is not your data. We call it data mining. Everyone should use my standard. I don't use your standard, use my standard. And data suppliers are not data consumers of the same data. Are we alone? No, it's a universal problem. As you can see, since 1950, you could see start with analog paper-based information to digital age. In 1980, we started BIM, and Dharma International established 1983. Digital twin starts almost in the year 2000. CDOIQ started in 15 years ago. Here we have now, yeah. So we only have 40 years, which is very short time. So we haven't really reached that stage of trustable data yet. So data life cycle is the key to understand the data. Okay, so we all have phases to achieve the data. The phase of use data here can only give you benefits. All other phases incur costs. So benefits can be asset information model, it's a project information model, but all other phases actually, is a cost. So as you can see, I mean, just to gain the benefit from the data, we have to have a lot of preparation. So I actually compare this as a rice farming, maybe not in the States, but in Japan, we have a lot of rice farming here. So through the year, we have a soil cultivation, preparation, seeding, planting, weed control until we really have rice here. But I compare this as data management. So we're building foundations, architecture planning, design enable, store operations, data cleansing, the store operation through the summertime, and use here in autumn, so that we can have a very nice taste rice. And we have lessons learned, improved data management. Okay, so here's the value of the rice. You can see a lot of preparations. It's just 2 months from 12 months. Actually, this is only the value produced. Okay, other months, it's actually the cost. Okay, data management, DMBOK version, chapter 1, described this way. Deriving value from data does not happen in a vacuum or by accident. I will rephrase this. Deriving value from BIM digital twins does not happen in a vacuum or by accident. Right? Please bear this in your mind. Okay, who is in charge of data management then? Which is actually CDO, Chief Data Officer. It's not only an IT problem, it's a business problem. And we need digital partners to create digital twins. So what are those partners? Yeah, this slide is not included in your handout. Okay, we have business management, IT management. We have 007, James Bond, and Q. Okay, so James Bond says what to achieve, my goal, what to execute, what tools require, how to use them. Okay, these requirements will be passed on to IT management. Q will analyze requirements, create system architecture, design and develop tools, and then provide tools. So these are the collaboration with two digital partners. But on top of that, we have CDO to support and sponsor these initiatives. Thank you very much.
All right, Mick. Thank you for using a James Bond analogy. He's one of my favorite characters.
Right.
We have a couple of questions in closing. You mentioned data mining. Really like that. Have the building information modeling standards led to widespread data sharing across companies in the construction industry?
Sorry, the last part, I couldn't hear that, sorry.
Yes, have the BIM standards led to widespread data sharing across the construction industry?
Yes. So, actually, I mean, how wide is it spread? Is that the question?
Yes, because we've heard in your presentation and others that the data hoarding and not wanting to share.
Mm-hmm.
So you described an industry data standard, and the question is, has having a standard actually contributed to sharing data across companies?
So it's very strong standards in the UK, first of all. I did the nuclear power station project in the UK. But then all the project in UK for public sector, we have to comply with BIM standard, which is ISO 9650. And then in Singapore, they all have to follow the standard. And then lots of new project coming up, and contracts specify that the contract have to follow the BIM standard. So the more and more people actually introducing BIM standard. Did I answer your question?
Yes, I think overall you're saying that having these data standards has contributed to sharing information across the industry.
Yes, at least people do not call BIM so easily, like this is BIM, that is BIM, but it's actually not BIM. So we need to have a common understanding of the BIM.
Okay, and then a couple of technical questions.
Yes.
Can we call a distributed control system's graphical user interface programs a digital twin?
Yes, it can, because it's actually it's been realized already. You know, in the plant we have a huge control room, we have a huge screen, which has it's actually not exactly 3D model, it's a CO2D model, but it's actually showing how the raw material is flowing and the levels of the fluid, and then the valve is shutting down, or it's actually reverting the flow. So it's all happening in the real time. So DCS we cannot build a plant without DCS. We call it instrumentation. So that's very advanced technology.
Okay, you're showing DAMA and the DMBOK and the wheel has inspired some in our audience. How can they get engaged with the DAMA organization and use the framework?
Right. First of all, please look at the DAMA homepage. It's very easy URL, www.dama.org. And then you can see the chapters. And if you can find any nearby chapters, just contact them, or even contact me. I am an Asian region coordinator. We have 4 coordinators in the American side, North and South, and the European and Middle East and Africa. So please contact these people.
Okay, last question, another technical one. Where does MBSE fit in with the 3 categories of digital twin?
MBSE?
Yes.
What is MBSE? I'm sorry.
Unfortunately, I do not know the acronym either. I thought maybe it was a common one. Let's see if it's model-based systems engineering.
Ah, okay. Model-based system engineering. So it's actually system engineering. So it comes at the very early stage of the design, and you can actually simulate the model to check whether that model works or reflect the reality or not. So it's model-based system engineering can be, of course, achieved through BIM and digital twin. And then I think it's right now it has been enhanced to incorporate more information into the model, and also not only one model but multiple models, and then we can actually examine how the multiple models can work together. So it's the philosophy of model-based system engineering is still there, but it can be achieved through BIM and digital twin. So it's a conceptual or the solution.
All right.
Right.
Mick, thank you so much for your presentation today.
Thank you.
I'd like to invite the audience to join us in the town hall that it will be starting in 1 minute. It's how we recap the symposium. It's meant to be an interactive session. So please come and join the town hall to cap off what has been an excellent 3 days of presentations. And again, thank you, Mick.
Thank you very much. Bye-bye.
This session is now over.